Cool.
You all good?
All good. Okay, so first we've got the Lynn's news, and I will hand over to Mike Judd. Mike.
Good afternoon, everyone. Trent, who was going to be giving this update today, unfortunately couldn't be with us. He had a conflicting meeting, so you get to hear me give this update on what the properties team is doing at Lynn's. So I'll start off first with the NZ suburbs and localities dataset that we're working on. And this is to replace the FENS NZ localities dataset. Our preparations continue to go really well as we set ourselves up to take on the responsibility and manage this dataset of NZ suburbs and localities. And we are on track to release NZ suburbs and localities in March 2023, so March next year. And we'll be sending out communications about that early in the new year. Now, just to note that the fire and emergency existing NZ localities dataset will continue to be available for a period of 6 months following the formal release of our new NZ suburbs and localities dataset, and that's just to allow for a transition to occur between the two. So that's a quick update on NZ suburbs and localities. Next slide. So the next thing is NZ addresses. So our So the NZ addresses dataset, now this is our most comprehensive national address dataset, and it contains approximately 140,000 more addresses than the existing NZ street address dataset. The NZ addresses datasets remained in pilot for a while due to a bug that resulted in inconsistent addresses, but we've successfully fixed that bug now, and that means that the NZ addresses dataset is ready to come out of pilot, and it will supersede the NZ street address dataset as the authoritative address dataset that Lynn's provides. And again, we'll be sending out formal communications about this in the new year. And again, NZ street addresses, there'll be a transition period, so NZ street address will remain available for about 6 months while we transition from that dataset to the new NZ addresses dataset. Okay, so and the next update from us on the next slide. So the final update I'm going to talk about today is the NZ Properties hybrid layer. So this is a layer which it's going to be a single layer available on the LDS, and it'll effectively contain the best representation, spatial representation of a property that we can deliver at the moment. So what it'll have is it'll have the NZ Properties unit of property layer, so our spatial property boundaries layer, and where there are gaps in that layer, we will fill those in with boundaries from the NZ property title layer. So effectively we'll fill in with title boundaries. And where there are still gaps after we've done that, we will fill that in with primary parcels. And on the slide you can see here, green is the unit of property layer, red is the title layer, and blue is the primary parcel layer. So this will represent the best view that we can give of a property at this particular time. Over time, as we improve the NZ Properties unit of property layer, that'll increase, and the infill from the other two layers will decrease. We're about to start commencing the build of this layer, and we expect a draft version to be available on the LDS from about March next year. That will be a draft because, of course, NZ Properties is currently in pilot as well. Excuse me. Sorry about that. Now the thing about this particular layer is that it will be, because it contains DVR data and is based, and that's controlled by the agreement we have with councils to use that data, the NZ Properties hybrid layer will be available only to central and local government at this stage. and again, it'll likely to be available in a pilot from March 2023. So keep an eye out for that one. So those were the three things that we were going to update you today from the NZ, from the Addressing and Properties team here at Toitū Te Whenua. Ben, back to you.
Thanks, Mike. I'll just pause for any questions and just quickly mention, I forgot to mention at the start, if you do have questions throughout, feel free to just pop them into the chat and we'll come to them, or pop your hand up through Teams and we'll likewise come to you for that question if you want to ask it out loud to the group. Either's good. So yeah, any questions there for those three data sets for Mike? Notice of change, and I'm going to pass to Mike Webster.
Good afternoon. Okay, so we are going to switch on the availability of XML files as part of the notice of change notification that councils that are participating in the notice of change service as of the 12th of December. So that means that councils that are currently getting PDF notifications of change will also have this XML file in that same email they get sent, and when and if they become ready, their IT teams can start puddling around with that XML and getting themselves ready to ingest the data they're sent in hopefully what will be a more efficient manner. So some of you will be aware we have a group of councils working on that XML ingestion process, and we have regular meetings. One of them occurred yesterday. If you're interested, please do make contact with me. Just indicate to Ben, and he'll make sure that he passes it on to me, or if you have my email address, just let me know. So yeah, that working group of TAs. Also, James Martin and myself are slowly working our way, meeting with software developers, encouraging them to think about XML integration into their property information databases, those products, so that hopefully where there's a software vendor that has a product that covers multiple councils, that they can introduce a solution that will work for multiple councils. So that'll do for me. I'll hand it back to Ben, unless you've got questions.
We'll just give a minute for questions for Mike. Okay, do feel free to drop them into the chat if they come to you later. Otherwise, we'll carry on. Ratings, valuation, and DVR rules review. We should have Kerry from our policy team to talk to this. Silence. Okay, I'll talk to it quickly. So, as the points say, the ratings, valuation, rules review has been kicked off, and any of you working in this area may know it's been a little while since the last review was conducted. So timely that we do that again. The initial focus is on getting an understanding of how valuation providers are managing and storing that data, and any improvements that can and need to be made in that area. And then also the structure and content of the DVR, things especially like land use classifications that I know some of you we've talked to before have indicated that you'd like looked at. We'll be looking at those. And so we're aiming to be quite proactive through this review and engaging with the sector, and leading with that rather than sort of coming out with a finished product later in the piece, we want to talk to customers early. So we will work through a process of identifying and reaching out to relevant stakeholders in that area in the new year. Any questions on the DVR? Nothing coming in the chat. Okay. All right, we will carry on. And now LiDAR, we have Abby from our elevation team to talk to the work that they're doing behind the scenes there and some news on that program too. Abby.
Awesome. Thanks, Ben. I'll just quickly request control because we do have a couple of slides to get through.
Yeah.
That's all good.
Yeah, and I'll allow.
Awesome. Okay, cool. Hello, my name is Abby Douglas, and I'm actually joined today by my colleague Emery Beck as well. So we both work in the elevation team at Tuitu Te Whenua, and our main role is quality checking LiDAR data. So today we're going to talk a little bit about the National Elevation Program, how you can get the data and what data sets are coming up for publication by the end of the year. And I don't actually know how to change the slide. Sorry. Do you mind just doing it, Ben? Apologies.
If you go down to the bottom left, there's a little control, some buttons pop up for you.
Oh, okay.
And there's a couple of arrows.
Okay, cool. Oh, that pop-up's not there. That's really random.
Okay, we will.
Would you, I'll just let you know when to change slides.
Yeah.
Cool, thank you. Sorry about that. So we mainly get LiDAR through the National Elevation Program, which was set up in 2016. So it is a partnership program between LINZ and councils to procure and make publicly available a nationally consistent, high quality baseline elevation data set for New Zealand. Next slide, please. Cool. So by 2024, 80% of the country will be covered with elevation data. Currently, we're at about 30%, which is the one on the left. Next slide, please. Cool. So what is LiDAR? So it stands for light detection and ranging. It is captured from an active laser sensor that's mounted on an aircraft, like the left image there. As it flies over the landscape, the sensor sends out a laser pulse, which is multiple, which are reflected off surface features back to the sensor. So the image in the middle there shows you what kind of light signature is captured by the sensor, and one pulse can return multiple raw points. So a number of points in a given area is termed a point cloud, like the image on the right. Next slide, please. Oh, sorry, can you jump back one? Thank you. So this is an example of a point cloud in 3D. Each point can have multiple attributes. So one of them is classification, which you can see, and it represents the surface features. So buildings are cream, ground is orange, and vegetation is yellow. Next slide. And so you can, sorry, do you want to jump to the next slide? Thank you. So you can download the point clouds freely available on Open Topography, and you can also create DMs and DSMs from Open Topography, like really high resolution ones. So I definitely recommend checking that out if you're interested. Cool, next slide. So there are two raster products that we provide that are derived from the point cloud data. So this is one of them. It's a digital elevation model, which is created from ground points only. So it's just showing the bare earth elevation. Next slide. And the second derived product is a digital surface model, which is created from all points except for noise. So this means that surface features above ground are included, such as like vegetation, which you can see in the image. Cool. Emery, do you want to take over? Next slide. Oh, sorry. Both raster products can be downloaded on the LINS data service. Yep, cool. Next slide.
And this slide's in here just to kind of highlight the immense amount of detail you can glean from these data sets and why they may be relevant and important for you know, incorporating into your workflows. With a bit of analysis and sort of data manipulation, you can end up creating and extracting, as I said before, an immense amount of detail, as sort of shown in this city of image of Wellington City. Slide, please. And with something that we've just recently tried, and one is now sitting on LINS's minister's office desk, is the ability to 3D print the elevation data as models. So yeah, just a bit of interest thrown in, a bit of visual eye candy for you all. Next slide, please. So not only do we want people to use the data, we also want to promote its use and sort of show and guide people, especially ones who just want to pick up this data and aren't too technically savvy. We want to provide the means to actually utilize this data. So as part of Elevation Aotearoa.co.nz, we have a bunch of how-to guides. So as an example, one on view sheds, there might be, I don't know, someone planning construction or new build sort of at the front of your property that's 5 stories, and you want to create a raster that kind of assesses what you can and can't see with this new build going in. So this is an example of something that you can do with LiDAR data, and a guide up there sort of stepping you through how you create that sort of product. As well, there's how-to guides for ArcGIS, more information on getting started with LiDAR data, some case studies and how it's actually being used in industry. And next slide, please. There's also a ECA release schedule that lets you know when new data sets are going to be released. And due to the nature of LiDAR capture and processing, these estimates do change. So it's one of those pages you want to probably have bookmarked on your computer and just refer to over and over again. Next slide, please. LINS Data Service has a Twitter page. We actively promote publishing new data through there. So again, if you want a good indication as to what's been published, along with a cool visualization, definitely check that out. Next slide, please. And I guess to kind of hammer home updates, recent updates, we are publishing very shortly Northland region. The next slide has a block 1 and 2 of Canterbury, so this will be grown to eventually full regional capture. And the last one we'll hopefully have published before Christmas is the Taranaki region, which is on the next slide. So yes, there's lots of updates, and this is definitely a watch this space situation. We'll be publishing a lot more LiDAR data in the very near future. Cool. And that's it. Thank you.
Sweet. I can see there's some people happy to see those new data sets come through in the chat. Any questions on LiDAR for Abby or Emery? All quiet. Okay. And just so thanks Abby and Emery. That was really good, and those visualizations are stunning, especially this one of Mount Taranaki. Yeah, that's cool. And just a quick note, we'll have base maps penciled in for the next meeting, so there should be some new updates there by then as well. Oh, I just see a quick question from Sam Keast in the chat. Any luck with getting Horizons region to sign up for LiDAR?
Oh, I can take this. The short answer is no. the sign up that we had when we started the National Innovation Program has closed, so they did miss out. But we are open to any LiDAR data sets that are captured that people want to make public. So yeah, definitely might be something in the future, but currently no.
Yeah, and I think there is some thinking going on around what comes after this program. So and continuing LiDAR capture nationally. So you know, if you've got any other use cases, any value propositions or evidence of value, we welcome those as well to feed into that that thinking around what next.
Yeah, definitely. Feel free to email us.
Yeah. Cool. Thanks again, Abby and Emery. And there's just some contact details there for the team, and we'll send those out with the pack after. And next we have Nadia from Wellington City Council. Hi Nadia, did you want to take over and share from your end?
Yeah.
We'll give that a go. I've got the slides as a backup if we need it.
Try to share. See if it works. Right. Can you see? You see there?
Can everyone see Nadia's slide with a nice animation there? Thumbs up, thumbs up. Or... Okay.
Yep.
Awesome. Thank you. Kia ora koutou. So I'm Nadia Webster, the Manager of Data and Insights from Wellington City Council. I probably, as usual, have too much to say in too little time. So I'm going to skim through the first bit and then spend more time on the second part. So this is just explaining a little bit about the approach that we're taking to, excuse me, to developing an information and data strategy, which is still in a bit of a draft state at this stage, but I was going to explain some of the aspects of what we're doing there. And then I'm going to just talk through a couple of examples of some work that we're doing around the property data space. So that we'll talk a bit about property search and notice of sale process. So this is very much coming off what was talked about earlier around notice of change. We call it notice of sale. It's kind of the same thing, but I'll get to that in a moment. So what I did earlier in the year was ran a whole bunch of internal workshops inside of Wellington City Council with a whole bunch of people, over 75 people, just to get a feel and understanding about what the outcomes for a data strategy or information data strategy they were looking for, what were the barriers to achieving the types of things that they wanted to be able to achieve, what were the opportunities, what would be on a roadmap, but also to get a sense and understanding of what the mission critical data for Wellington City Council is. And I used the government's data strategy and roadmap just as a framework to have that conversation, which was just a useful way rather than just sort of having it all over the place to get people to think a little bit about the different facets of a data strategy. But for us, we, instead of putting Te Tiriti in the middle, we put in Tupiki Ora, which is our Māori strategy for Wellington City Council. So as a result of those workshops, what I've done is developed a little bit of a maturity model based on all the information that came through that. And there are lots and lots of different maturity models around information and data analytics maturity, including DARMA, which is one that people are probably quite familiar with when we're talking about the data management side of things. But I was trying to have produce sort of a maturity model that made sense to a broad range of people and who looked at it from different perspectives. And I couldn't really find something that really spoke to that. So I've adapted a bunch of different ones, including ones from Statistics New Zealand when they're looking at capability, but also at looking at it from a systems point of view, a data system point of view. Adapted ones that sort of talk more about maturity around data analytics, but also I've incorporated Dharma into here, and this is draft at the moment, and we'll see if it flies and see if it makes sense for the organisation when I send it out for further feedback. I haven't put the detail of the different levels in this presentation because it's still being worked through, but essentially the different facets of this maturity model are around these different headings I've got here. So the discovery and availability, so the ability to be able to identify, connect data and information together, and also the ability to be able to have open, properly manage open data, shared data, identifying data and information of significance to mana whenua, and then give them access to that as well. So I would say roughly we're kind of at the first level in that stage. A lot of people in our workshops talked about not knowing what we had, not understanding its quality and things like that as well. Then there's culture. So actually viewing data and information as strategic value to the organisation and also to the broader system that the organisation works in. But in this stage, we were sort of at that very sort of maybe 1.5 maturity level, because we still see data information, but data in particular, as a byproduct of a lot of the processes that we have inside the organisation. So we're still not at that level where we're really understanding across the board how important it is to be able to support us in delivering to our strategic directions. And then in the analytics space, that sort of ability to be able to use data and information to inform decision making and inform strategy, we probably still at that sort of 1.5 level, which is speaking more to we do analytics to tell us what happened. Then level 2 is more at about telling us why it happened, and then level 3 might be more about using analytics to help us to work out how to make something happen. And we're still very much at that sort of 1.5 level maturity. Governance, definitely around that whole organisation-wide and down to the data set or information set level of governance. We're still sort of relatively immature, not understanding the role of stewardship, and then looking at it from an information security perspective, and looking at the maturity model and the protected security requirements. We're still at that very basic level as well. So we've definitely got work to do there. And then also recognising the importance of data and metadata quality that aids in our ability to have discovery and availability of data. Then there's data architecture and data modelling and design, and I would say that that's done very much, data architecture is sort of done very much at a system bespoke level, looking at the process or business unit that a business unit's trying to achieve, but not necessarily looking at it from the perspective of being able to get greater benefits from information and data that flows through a process. And then at technology level, we're starting to move more. We do quite a lot of work in the integration space, but I think we're starting to move more into the data warehousing space now, and we need to lift our maturity there as well. So out of those workshops also has emerged, as I said, these are still draft and being getting feedback from the rest of the organisation on these really high-level strategic outcomes that we're looking at. So the first one there, people can use information and data and analysis to improve the council's performance, understand the history of Whanganui Tara and the council, and plan for the future. So across the organisation, these are the types of things that we need to be able to do. But also, when I say people, I'm talking about external people, so the members of the public or other people within the broader data system that we work within, and including in that is mana whenua and their ability to be able to use the information and data. So that's where we come to the second one. We need to work with our newly established partnership with mana whenua to understand what they are looking for with regards to Māori data sovereignty and governance. So we want to be able to identify their needs. And in order to be able to do that, we need to identify what types of information and data that we have that might be of significance to them. and that we support them in achieving their needs. And the third one is really about, and I think this is the same for many organisations, is it's important that an organisation has trust and confidence in its decision making, both internally but also from the public perspective as well. And so we want to be basing that on reliable and robust information data and analysis that comes from information data that's been really well managed and understood. So those are the high level strategic outcomes that we're looking at. And then from the workshops, we've also developed this sort of high level data model for the organisation that looks at the organisation from the perspective of the different data domains or data and information domains that we work in. And this doesn't describe the entire organisation, but it probably describes the core of it. So at the bottom, we're talking about the environment, the physical geography, geology, climate, the base layer that everything that a territorial authority is going to sort of work from. And then all of these sort of human constructs, so the construct of property, and as we've talked about here, the addressing, the boundaries, the geolocation, the value of that property and its ownership. And then on top of that are the things that we do on that, within that environment and on different pieces of property. So we're either establishing assets or we are doing activities. Activities might be resource, impacting the environment. So resource consenting is a permission for doing an activity, or an activity might be building a building or doing some earthworks, or it might be having an event at Frank Kitts Park, for example. So, so there's quite a lot of data and information associated with that. And from a systems point of view, it's really important that we have the ability to be able to extract data and information that helps in understanding our regulatory compliance and being able to report that to the broader regulatory system that we work within. On top of that is the public. And so that is how they interact with assets, activities, property, and the environment. And then the services that we provide, which might be, so an asset that we provide might be a swimming pool. And the activity that we provide in that swimming pool is providing swimming lessons. Sorry, the service that we provide within that asset might be providing access to swimming pools and swimming lessons and things, for example. The top 3 ones are really just generic for any organisation. So in any organisation, you're going to have governance, you're going to have finance, and then staff. So, there's quite a broad amount of information data that we have to have a good handle on in there as well. Just quickly moving on, and I will gloss over this very quickly, but the concept here is how we would develop our action plan, and we're populating this at the moment. And the idea is to be able to say, we want to lift our maturity level from here to here in these different maturity facets. The activities that we would do now, next, and later. So I haven't really got a timeline in there. It's more a case of relative order of things. And then the little coloured markers are more about, is it black is sort of indicating whether it's a foundational piece, but we would want to use one of the data domains as a pilot for establishing some type of foundational piece. And then how that how those actions will deliver to the outcomes that we're trying to achieve. So my 2 examples, now I'm going to run out of time, of pieces of work that we're doing to establish some capability. One is around property search. Now, one of the things that's really not everybody, and I never really understood until I got into working at Wellington City Council, is that properties change addresses over time. So what we found is that we end up through our regulatory process, for example, building consenting, a building consent will be consented to a particular address, and that particular address might change later in the life cycle of the property. But if we want to be able to provide LIMs, so land information memorandums, or help somebody if they request all of the building consents related to a property, to an existing property, we need to understand the ancestry of that property in order to be able to find those documents, in order to be able to deliver them. So the user story we're looking at here is, as a person looking for council information relating to a property, I want to identify the correct property so I can be confident I'll find the information, related to that. So, for example, all the building consents. So to illustrate what we're trying to achieve, this might be what it looks like, where somebody selects an address and then the property is displayed. And so it's showing the property boundary, and then the user might say, yep, definitely I'm going to place my marker on this is exactly the property I am interested in. Because sometimes we need to know, is it in this corner or that corner, for example, or we're talking about this part of it or not, because it gets quite complicated when you're talking about different boundaries, as I'm sure a lot of you know. So inside the organisation, or programmatically, if once we get there, we might want to be in a position where, because we've had that confirmed, we can now see the ancestry of that property. So this is an example of a property that over time has actually changed. It's the same property, or it's related, and it's changed its address over time. So you can see here that the top line there is the status is current. So that's the current property, the current address of that property, but it has changed over time. And so we want to be in a position where we can, through an API, be able to reach into our information systems and pull out the specific service requests that are related to that property through its history. So that's the one example. And the second example I'll talk you through is the notice of sale. So this is the notice of change process. Notice of change means change of ownership or change of information about a property. And so one of the things around this is that at Wellington City Council, we have our own bespoke database. That's our property database. And we have been receiving for quite some time now the emails from LINZ to alert us to say that a property has been sold, or there's a change of ownership details. So what happens is, so prior to this new notice of change process that LINZ has put in, solicitors might contact us by email, or they might go to QV and fill out their form, and we would get lots of information from different channels and different formats to tell us that a property had changed ownership. And what's happening now is that the solicitors the conveyancing solicitors who are processing that, they go to LINZ and they fill out the form with LINZ, and then LINZ will send the daily email of a PDF file to the territorial authority that looks after that property. So what's happening in our team at the moment is that there's a manual search and retyping of that information from those PDF files, because our system that we use was built in the 90s, and the interface that we've got only allows for retyping. You can't even copy and paste. So we do that by checking through our property database and our owner database, and we're looking to match the property details that come in those notifications from LINZ, so that we can correct that and make that change, so we can update the contact details for the owner, because it's really important that we have contact details so that we can send them a rates bill, because that's really important to territorial authorities, so that we have and then what we do is we do a daily wrap up of all the changes and send that on to QV, who maintains our DVR for us. So this is our process at the moment, and the majority of those notices, of which we get about 400 to 800 per month, the majority of them take about 15 to 20 minutes per notice to process. Sometimes they take a lot longer because we've got insufficient details from the solicitor and have to go and check that information. So what we're aiming for is to have a MVP, so a minimum viable product, by July 2023, which takes full advantage of the XML files that we also get in the same email from LINZ. And to do this, because we have a bespoke system, we're actually putting in our own bespoke system to be able to consume those XML files. So what it's going to do is take those daily XML files, load them into a database, And then that'll bring them up onto a selection window where our staff can select which notice that they want to look at. And then when they click into it, we have some matching algorithms that are going to suggest which property and which customers this might be related to. So it's basically doing an automation assist to doing the processing. And so that property matching, at the moment, we do this by comparing the title ref, the val ref, and then some other factors as well to try and narrow that down. It includes a little bit of natural language processing because of the, for example, the property address itself, the way that that's being provided to us in the XML, it's not consistent. And many of you people have already mentioned that we don't have a standardized way necessarily of naming, say, an apartment or a unit or something like that. So we do have to use a bit of natural language processing to do this. For example, people might say, why wouldn't you just use the legal description? But that's not unique. And internally, we've actually over time added additional text to this field in our database, so it's not really a territorial field we can use. We know that in the future, LINZ wants to provide the territorial authorities with their own property ID. So that will be collected from the DVR and then basically cycle back round to us. So it's going to be a lot easier for us to match in the future. And the other part that we have to do is matching the owner. Now that's a lot harder to do. With matching the property, we're getting about 70% accurate matching, but with matching the owner, we're getting sort of closer to about 50% with existing owners. Now, one of the reasons we wouldn't get a very high match is because, of course, around 40% of those new owners are going to be new owners within the Wellington region or new homeowners to begin with. So we wouldn't have them existing in our current customer database. So our team would then accept those suggested changes. If they aren't going to accept them, then we're making it a lot easier for them to actually to process it then and there. You'll notice we've called our app Sales Notice App or Snap because we wanted to give it a good name that would be really memorable. So what Snap will do at the end is then package that email up into an XML file, and then we can, at the end of the day, and send that to QV. Now that'll be in the same format that the LINZ XML file is coming in. So in the future, we would want to see APIs at either end of this rather than files being emailed backwards and forwards. And just noting that our MVP is what we've called the happy path, which is only going to work for single rating unit and single title properties. When it gets more complicated, that's going to be the sort of the phase 2 that we're wanting to do, which will add in things like subdivisions. And subdivisions are a more complicated scenario. And so we might never be in a position where we can do straight through processing for 100%, but we're hoping we could get to the point where it would be 80%. So one of the things that we've done with our team is we have been doing testing our matching capability. So we've been, for over a couple of months, we've been putting what our matching algorithms would suggest is the right match and putting them into a spreadsheet. And as the team do their manual processing, they tell us whether the match was, how close it was to what they consider to be true. And this has really helped us to understand and improve our matching, but it's also helped with the change transition for the team and for them to get that confidence that this tool will be able to accurately assist them. So overall, what we're aiming for is, instead of the majority of notices processed in 15 to 20 minutes per notice, we're hoping it to be majority processed in 5 minutes or less. And then overall, we are aiming for improved data quality and improved data availability as well. So that means it'll be a faster process getting accurate contact details through this process and onto our rates team, so that when we are sending rates bills out, we are definitely sending them to the right people. So that's all I've got to say. And I know that was a lot all very quickly, but let me know if you've got any questions.
Hi Nadia. No questions, but I was just very impressed with the range of different tools and algorithms and techniques used to do that processing. I'm a big fan of natural language processing myself, so that's pretty cool.
Thanks, Jared. We've just got a question from Kim in the chat. How do you handle history?
How do we handle history? So we historify the properties as they change. So I probably am best to ask Michael, who's on the call, to give a little bit more detailed explanation of that. Are you able to answer that one, Michael?
Yes. Can you hear me?
Yeah.
Yeah. Our property started in 1999. Every change that's happened since then, we've kept full audit history and the relationship of every property leading on to something else. So that means there's no problem at all for the last 22 years. At the moment, for anything that goes back further than that, we have to rely on indexing of the historic records. But at least it's good for everything from 1999 on, because nothing's deleted in the relationship of properties created and their relationship between their ancestors and descendants.
Just some praise from Graham in the chat. I like the outside the box pragmatic thinking. Thanks, Graham. Any other questions? I think just don't be worried about time. We didn't have many questions for the first item, so we're running a bit ahead actually. Nadia's finished like right on when she should have been starting according to the agenda, so
Okay, good.
We're about a segment ahead of time. So feel free to fire away with any questions.
And what we will do, once we've started to establish it a little bit more, we'll quite happy to publish or send out the approach that we've taken, and especially how we're doing that matching. And I know that, so there is an XML working group that Lynn's has brought together, and we just met yesterday for the last time for the year. And there are a number of different councils who are really interested, particularly in how do you do matching of the owner record. One of the things that we're trying to do is actually separate out the property owner / ratepayer record from our customer records, because the customer records aren't so well maintained. And if we were to be trying to check against that, and that's customers sort of across a bunch of different services, if we were to maintain against that, then the overhead of trying to maintain that's really hard, and it actually makes our notice of sale processing a lot slower. So we're zeroing in just on the owner ratepayer records to be able to match against.
Okay, thanks a lot, Nadia. That was really interesting, and I know, yeah, I think those lessons will be really helpful for other councils and even for Lynn as we progress into our own thinking around a data strategy. So yeah. Next up, we have got Matt Blythe and David Knox from Linko Analytics. Again, do you guys, hi Matt, do you want to share from your end, or do you want me to share? And
Afternoon, Ben. If you share to start with, then I'll pass to David, who will do a demo from his screen.
Yeah. Okay, cool. I will just share again. This screen.
Perfect.
Has that come through?
It has. It has. Thank you. I'll just give you a nudge to move on as we go. I've got about 4 or 5 slides to start, and then I'll pass to my colleague David, who's just come on screen as well. So good afternoon, everybody. We Linko. We today want to talk about turning all that great open data into really added value insights. So we've called this talk Data Not Pixels, and we'll focus today on a project that really we think has a good sort of resonance and alignment with the property network and the conversation we've been having on these sessions. It's a project for Christchurch City, looking at deriving from recent aerial photography, roof material and condition. And I'll explain the purpose of that and how we've done that. And David will take us into the map and we'll look at how some of the models we've built are delivering some outcomes to the council there. So if you take me forward one, Ben. Just in terms of, I guess, our mission and what we do, we're really an integrated team of data scientists, of GIS practitioners, remote sensing scientists, and data infrastructure engineers. And we think those sort of three skill sets are quite complementary in this day and age to allow us to apply some of the, I guess, the new technology sets that have emerged in the last 4 or 5 years, particularly around computer vision, particularly around cloud computing and sort of clustering, large compute GPU servers, to allow us to really work with some of these very large data sets. So we've been kind of operating the space for 3 or 4 years now, spanning satellite imagery, aerial photography, UAV or ROV, so underwater remote operated vehicles, LiDAR. It was great to hear the update today on what's happening with LiDAR. CCTV, a lot of CCTV in place in New Zealand cities in particular, that has latent value, but it's very large, often video data streams. So to turn that into useful information, requires a process and a clear plan. So we kind of integrate. We bring together neural networks, different other AI techniques, and there's a sort of developing field, excuse me, called explainable AI, which is also sort of designed to shine a light into the black box and to allow a better understanding of how a model is making a decision. So pretty fast moving space, and we kind of follow that overall kind of trend of AI for Earth observation, AI for EO. You'll see that little sort of hashtag at the end there. Pretty fast growing field, and I think a great opportunity for New Zealand to leverage, and it ties in nicely, I think, to the good work councils, LINs, and other government departments are making with regards to data interoperability and openness. So if you take me forward one, Ben. Before we come to the Christchurch study, I just wanted to give you a little sense here in a few minutes of, I guess, some of the range of the sorts of applications that can be tackled. We've probably run 40 or 50 projects now in the last couple of years across that sort of spread of data that I mentioned. Now, the talk today will be at the bottom centre, the roof material and condition one. But just before that, we, referring back to the LiDAR data earlier and the great talk from Abby and Emery, we've, for Harrison's Energy and Homes or Trade Me, derived a solar economic value score for a rooftop using 2 of the LIN's open data assets, the LiDAR point cloud and the building footprints. So we've run a well-established and known, this is not an AI project, but a well-established and known routine to determine solar receipt surface, and then correlate that to the retail price on average across New Zealand for a 3 kilowatt and a 5 kilowatt system, which are kind of the 2 standard residential household systems. If you're interested, a good house in New Zealand can yield about $2,000 per year of value. So that would be the discount off your power bill per annum. A poor house in a very shaded or occluded area with not great sort of north-facing slope will yield about half that. So that was a fun product, and that's sort of now available free actually for people to look at and get a feel for what their property looks like on homes.co.nz. Top centre is a really important area that we work a lot in. We've done, I think, 6 or 7 cities in New Zealand where we've derived a detailed land cover map. I think it's a 9-class data set, exploiting those really high resolution RGB pixels that most cities are flying sort of every 3-4 years on average. And just referencing back to the Churton Park example Nadia showed, what we've done in that case right at a property level is to be able to separate the impervious from the pervious surface, or look at the makeup of that section that has relevance to a lot of different uses, and particularly for sort of flood modelling and actually looking at also consent requirements really. And if you could think about things like swimming pool detection or offsets, size of properties in relation to the boundary, these are the sorts of downstream applications that can flow from that. Top right, funny one here, we've done some work with actually the Colorado state government and some of the environmental bodies over in that part of the US, looking at the importance of beavers on the wetland habitat. If you take me back still, Ben. There we go, thank you. So this is using a different technique called object detection. If you think about facial recognition or vehicle detection, it's a type of modeling that allows you to really pinpoint a feature. It's trained based on supervised learning, where we train a model to understand the shape or the structure or the color or the texture, the things that relate to that object. And then a model over time can generalize and be quite a useful, robust tool to find, in this case, beaver ponds. And we've just finished a project here where we've detected, I think, 40,000 or thereabouts beaver ponds across the Colorado River Basin, and a certain amount of surface area of water. And if any of you have been to that area, it's a very dry area. And so beavers actually have quite an important role at kind of preserving hydrology and water retention in the catchment. So they're now more appreciated, shall I say, in terms of nature-based sort of agents of looking after the environment. The bottom left example was some work with now Sentinel imagery, very, I guess, coarse, but also open data from the European Space Agency. This was a study for the World Bank in the Horn of Africa, where we were looking at changes in pop-up settlements, if you like, often refugee camps, but also could be migration groups, or there could be social unrest implications that are occurring in parts of Somalia, Ethiopia, Tanzania. So in purple, dense structures, yellow, reduced density, and no structures is kind of the background, and you'll see some of the raw imagery appearing beneath the surface there. So we were tracking over time with Sentinel over, I think it was 5 years, changes in urban density as a proxy for investment by the bank into, support and other humanitarian efforts that are ongoing there. And on the bottom right, I think this was mentioned in a previous network catch-up, we are working with LINZ to essentially update the property building outlines for councils and for LINZ. As new imagery comes off the conveyor belt, it comes through to our process, and we are applying a number of different models to derive those geometries, those building footprints. So, but I'm going to talk now, and shortly I'll pass to David, about our roof study in Christchurch. Next slide. So the goal here was to see if we could help the City Council understand the type of roof, so the material, and also the condition of particularly metal roofs. The primary goal is to understand the heavy metal load at a catchment level, and for the City Council to work out how to prioritise and where to focus on remediation or intercepting heavy metal particulates that might be entering the stormwater system. So this is a data set that's not really easily attained. When builders are consented, the roof materials may be recorded. So the DVR has some level of data on this, but it's not really a maintained data set, and certainly condition is not an ongoing focus, and it's not really available anywhere. So if we go to the next slide, we looked at two approaches here. We looked at satellite imagery, and we had a hypothesis that potentially the infrared band out of the Airbus Pallades, and we looked at Maxar as well, could assist. So we wanted to explore that and explore the spectral relationship of the 4 bands and the combinations of those bands to roof material. And secondly, a far higher resolution data set for Canterbury flown in 2021, late 20 and early 21, at 7.5 centimetres over the city. We clipped the building outlines out firstly, so we reduced our total surface area to, I think it was approximately 220,000 rooftops. And then we moved into the machine learning phase. So next slide. Okay, we developed 4 models. So the first one was to test the remote sensing scenario. Could the satellite imagery give us a strong detection in the signal and separate particularly metal and non-metal? Secondly, a deep learning, so a machine learning approach as opposed to a remote sensing spectral analysis, where we were looking to use a technique called active learning, which is really a supervised labeling technique. Draw your attention to the diagram on the right. Active learning allows you to take an unlabeled data set, add labels, that'll allow a model to produce proposed labels. If I take you around the sort of a clockwise rotation, model 1 trained on a rudimentary number of labels, maybe a half a day or a few hours of training, can then produce proposed predictions, but also a confidence of prediction or an entropy score. And we surface those entropy scores back to our human trainers, and that allows us to train the model slightly faster and focus it on where the model's still not learning as well. And that could be for lots of different reasons, and David will show a few examples of that. For example, trees overhang roofs. Some roofs move between two materials, particularly large industrial roofs, or there may be decay in only some part of the roof, not the other. So the model might think it can understand a nice corrosive galvanized roof, but if the roof has combinations of surface presentation, there'll be some entropy, if you like, or confusion there that might present. We then looked at condition. We were looking for really good to poor, and we were essentially trying to correlate the number of poor or decaying roofs with a catchment to allow really a prediction or an assessment of the likely stormwater heavy metal load. And then finally, this was quite interesting and sort of relevant to this forum. We then put together an ensemble model, which David will talk to, which integrated the DVR data. So where DVR had some useful data, for example, the decade built, we could use that as a guide. The model could benefit from that piece of information. And particularly in Christchurch, where we have obviously the major event in 2010, 2011, and there was a lot of major change occurring with re-roofs going on right after the earthquake. So we wanted to sort of tease out that data point and make sure that the imagery was sort of validated really by any good available data. So with that, I'm going to pass over to David to take the screen and just show us some of the model results. Over to you, David.
Great. Thanks, Matt. Thanks, Ben. Hi, everyone. I think I'll just dive straight into the map and then we'll see how that looks. I'm going to take a risk and share my whole screen. So, okay, so I'll start with one of the problems that we had in training this model. So the first thing was just a really simple metal versus non-metal, and then we go into condition of metal, and a bit of work that's ongoing at the moment is looking at different types of metal, so separating colour steel from galvanised, for example. But what I'll show you today is just metal, non-metal, and then condition of metal. So I just want to highlight one of the big problems with that. So we're using, for the most part, the 7.5 centimetre urban imagery from Christchurch, flown in 2021. So it's very, very detailed, good imagery. It doesn't totally align with the published building outlines, but it's close in most cases. In the middle of the screen is actually, it's not a Christchurch roof, but this is a metal roof that looks like tile. So this is dichromastic or metal tile. So it's tile, but it's normally, but it is metal. Whereas normally with, tile, we're thinking non-metal, some ceramic type thing. Okay, so I'll just zoom to Christchurch and show you what the data set looks like, and then I'll go back and talk a bit about how we train the models. On the left map, actually, I'll go to a different one. I'll zoom out. It's a bit. So on the left map, you can see so the symbology. Red dots is the centroid of the building, where we think it's metal, and green dots we think it's non-metal. On the right, same location. The yellow dots, the symbology there is condition, and the large yellow dot is we think poor condition. So that's a problem for runoff. So for the stormwater and so on. So if I zoom in on one of these, and I did prepare this earlier, we can see it's metal and it's poor condition. So that's something to worry about. So that's where we're trying to go. And this data, I mean, it's useful at a property level, but also you know, the initial and main use of this is sort of summarised to a catchment and looking at what the sediment load is going to be in the different water bodies. So I've got a few more examples. Here's some examples of tiles which are I believe not metal, and it's correctly got those. Okay. In the map now, in roughly the centre, hopefully the screen's caught up. There's a new subdivision, and it's noteworthy in the lack of these big yellow dots. So we think it's mostly good roofs, which it should be. Mostly metal, and yeah, the condition is good. So just to the south of there, we've got an older subdivision, and we can see a mixture of materials, which, you know, often older subdivisions are more diverse in their building materials and everything. But you know, we've also got some degraded roofs, which is interesting, and that's what we're trying to find. Okay, right, I'll talk a little bit about how we train this. So as Matt said, we use a process called active learning. So active learning, that's just sort of how we gather the training data. So on the screen now, you can see this is just an internal tool we use. It's a little internal web page that we use that surfaces up these images. So as Matt said, we've clipped out the imagery. So this is the imagery that we get from LINS, and actually we use the imagery off of LINS's AWS S3 bucket. So that's sort of the fastest way for us to access the imagery. So we clip it out to the building polygon, and then we can make a judgment here. Now, in the background, I'll just switch to another project that's roof condition. You can see behind the scenes, there's a neural network model that's made a judgment based on this picture and based on the training that it's had previously about what class this picture belongs to. So we're saying good metal or bad metal, very simple. This thinks it's bad metal, and this is my chance to correct it. If me as the human expert, or I'll pretend to be the human expert for today, thinks it's wrong, then I correct it, and the model learns from that. Yeah, so that's that. Now Matt talked about the ensemble model. So we had these two models. We had this remote sensing model based on a 4-band satellite imagery image. It was fairly low resolution. We got maybe better than random out of that, but not good enough to be useful. This machine learning model, I've got a document here that's got some of the classification accuracies on a holdout set. So it was pretty good at detecting metal. Less good at detecting non-metal, but that's okay. We sort of err on the side of detecting metal because that's the problematic stuff. And then, so an ensemble really just means you're combining multiple models in some way, hopefully with some sophistication rather than just averaging. And we combined this neural network prediction with the DVR data, and so there's roof condition, roof material in the DVR, which as Matt said earlier, it's not the most reliable, but it's not completely random either. So there is some value in it, particularly for newer records. And by combining, we combine those with a library called InterpretML, which is a explainable AI model, and so some of you may be familiar with random forest and other models, which you can apply to tabular data quite easily. They'll give you a feature importance. So the input data, it'll tell you how important they are, but it won't necessarily tell you why. So this InterpretML, it'll give you that feature importance, but it also, per prediction, tell you what contribution each of those features made. So we can see why the model's made a particular decision. Anyway, combining the metal, non-metal detection and the metal condition model in the DVR model in this sort of hopefully intelligent way. But we got a small but important increase in accuracy in both our metal and non-metal detection. That's really all I've got. I can happily scroll around the map and look at things if anyone would like me to, or any questions.
Thanks, Dave. There's one more slide actually. I might
Sure.
Ben, if you grab the screen back, just summarize. If you go to the last slide, then we can open back up. Skip ahead, yep. So that was the accuracy results which David described. So one more. So the final, you saw the model accuracy there, sort of 97%. What we did then is we provided a floating point number for each metal roof, which was really a decay index. We coined a decay index. And here's sort of three examples, I guess, of the range here. So the very left-hand side is a very good quality roof, very low decay index, 0.002. The centre, we've got some level of decay there. And that's a good example of that occlusion that I mentioned. You've got the vegetation maybe over 15% of that rooftop, but it's still managed to identify the general condition pretty well, which is good. And then on the right-hand side, that example of a pretty old and decayed roof, which is probably contributing quite a large load of heavy metal. So council now working with that and looking to work with homeowners on remedies, or even for large industrial owners particularly, potentially offering to paint those roofs or work with the landowner, because the cost of remediation is far greater sometimes than just getting up there and applying some recovery to the actual roof. But the first thing is you've got a measure to manage. So knowing the state of the 220,000 rooftops was the first goal, and we were pretty pleased. And I guess it was a 2-3 month project to produce a result like this. Certainly sort of shows, I think, the efficiency value of again that imagery that's sitting there and it has latent value. It just needs to be exploited. If there's time, Ben, we'll open up for questions.
Matt, I might just jump in with a couple. So one thing that jumped to my mind was louvers. Does the system have problems picking up louvers that can rotate, and whether it's calculating whether it's extra roof or not extra roof, or permanent or new, or do you have run into issues there?
Yeah, look, there were big industrial roofs have air conditioning units on them, even solar panels that we talked about earlier. Those sorts of features can reduce the confidence of the prediction. But a bit like this middle example here, providing there's enough of a presentation of area, the model does fairly well. And so it's sort of more trained on the general total surface area, as opposed to object detection, the Beaver Pond example, where you're looking, for example, to find solar panels or find air conditioning units. With this sort of model, it can be a little bit more forgiving, given the sort of the whole roof context.
And the second one was around DVR. So you mentioned that DVR is not roof material is not something that's potentially not recorded or not maintained. If it is recorded,
yeah.
Is this possibly a technique where we could sort of feed back into the DVR and take up a bit more active maintenance of that data set or materials data sets within that DVR?
Look, I think so. I mean, and maybe whether this is a forum, we could potentially sort of start that discussion. I'd probably defer back to council and see if that's, I'd imagine that's useful to them. And if therefore it's useful to them and to QV and the valuation industry, then it's certainly a technique that could be then universally applied, as a orthophoto set is released and updated. It needs to be the very high resolution. So it might create an urban-rural divide challenge to think about for rural towns that don't generally have that high resolution data. But it is it's a source to potentially add some new value or some change detection value to the DVR.
Yeah.
I think that change prediction could be quite useful, particularly if people have been able to re-roof and didn't need a building consent and the council wasn't aware of it. But if you can detect definite changes, then that will impact on the value of the property, and be good if it can be fed back to the valuation service provider.
Yeah, I agree, Michael. It's a good point. I think there's probably over time going to be a possibility for government-owned models or government-commissioned models to play a role in data updates, property data updates.
Yeah.
Sort of matter where do we get to that, and how can all the councils get on board with I guess confidence and trust in those sorts of systems. But it could be quite a good future to allow us to pick up these sorts of changes more often.
And the Christchurch one's probably a good example too. I wonder how many of the roofs there were changed without the DVR being updated. So, yeah, there's definitely some potential there.
Yeah, thanks, Michael.
Steve, have you popped up with a question turning your camera on, or are you just getting ready for the next segment there?
I was just concerned how I was going to look.
Fair enough. Okay, so I think if there's we'll just give one more shout out, one more chance for questions for Matt and David. Otherwise, we will move on to Steve from Critchlow. And I'll just hit next.
Thanks, everyone.
Thank you.
Thank you, Matt and David. Yeah, really great preso. We might just, there's a late question come in. We'll just quickly do that before, sorry, Steve. How do you split training validation data for the model? What is the accuracy of these data sets?
Yeah, hi Saga. So it's geographically done. So it is draw a box on the map. Within there, we're not touching that in our training, but we'll use that for our accuracy assessment at the end. There were some tables of F1 scores and confusion matrices and so on in the presentation. But yeah, if you want to send us an email or drop us a message, we can provide more detail there. How's that?
Awesome, thanks for that.
Awesome. Okay, next up we have Steve Critchlow from Critchlow Geospatial, talking to the New Zealand satellite imagery marketplace. Fire away, Steve. Did you want to start the sharing, or are you happy just to give me a prompt?
But if you can make it so that I can just click, that might be easier. Can you do that?
It didn't work when we tried Abby taking control earlier, but if you just want to hit share the standard way and take over that way, it should work.
I don't see that. Oh, there's share. Yeah. I could share my screen.
Yep, I can see that.
Yep. Okay, so what we're talking about here is a little bit related to what Matt was just talking about. It's pixels, huge numbers of pixels, and in our case, getting them into the country and into the hands of people like Matt and all the other data scientists and analysts that are keen on understanding. So what we're finding is that an awful lot of studies and land use decisions and mapping is based on this blurry picture here, which is 10-meter Sentinel-2. And the attraction of Sentinel-2 is that it's free, and pictures are taken very frequently, and basically the European ratepayers are paying for that to be taken. But you can do a lot better if you want to get insights. And on the right-hand side is an image from SuperView, which is a constellation of Chinese satellites. that we represent. So we've set up basically what we're calling a marketplace because lots and lots of these satellite operators have approached us and said, would we be their distributor in New Zealand? And by and large, we say yes, because they've all got something different to offer. So just to sort of spell out perhaps where the imagery fits, there's different types. There's the obvious high-res colour that we're very familiar with, whether that's aerial imagery or satellite imagery. It's just a camera at a different height. And multispectral is different wavelengths that we can't normally see with our eyes, like infrared and things they call red edge and so forth, but just different frequencies. There's some specialist imagery around satellites that pop over here about 10:30 at night every couple of days and take nighttime imagery, which you'd question why, but obviously someone finds it useful. And you can also get reasonably high-res video for, say, 60 seconds, just focus on a particular area of interest, and that can be downloaded and you can view what's going on. Hyperspectral is sort of out there on the edge. There's very large amounts of data, and I'll show you some examples later, particularly useful for looking at perhaps the state of crops. And then radar is quite different again. This is where instead of capturing reflected light in a satellite camera, the satellite will actually be transmitting its own energy down to the Earth and then capturing the reflections coming back, just like any radar does, whether it's on the front of your car or in an aircraft or for picking up aircraft approaching you. But these are radar satellites that are going around, and they've been going around since 1970s. So it's not a new thing. But what is new is you can kind of control them yourself. And derived from that, you can get 3D elevation models. So what we're talking about is really different degrees of detail. Someone not muted? So it's pixel size, say from 100 meters up to 0.1 of a meter, 10 centimeters. You know, typically at the 0.1, that's where Matt was just showing us some really detailed aerial imagery of Christchurch. And, you know, you can do even better if you're flying drones a couple of meters above the ground, looking at potato leaves or something, looking for aphids. So it's horses for courses. So these are great. And open source satellites tend to be down at the sort of medium to large size pixels. So we're talking about this stuff in the middle from 10 meters through 5 meters and down to, say, 0.3 of a meter. It's difficult to get native imagery pixels from satellites that are bigger, smaller than 0.3 because it's a licensing issue. You know, it gets into classified territory, so you don't see many of those. You can apply sort of super resolution, they call it, to sharpen any of these images up, and that's where you get into the 0.15, say, double resolution of a 0.3. And the other factor to think about is really how much is it going to cost. Everyone always wants to know what it's going to cost and how long is it going to take to get delivered. So if we're talking about wonderful LINS data service aerials, it can be months and it can be years sometimes before the image that's been taken ends up in the data service for us to look at. At the other end of the spectrum, expensive. You can task your own aircraft and helicopters or task drones if it's a smaller area, but expensive. So sitting down here in a nice sweet spot of delivering imagery within hours or certainly just a few days, depending on the weather, I guess, You've got satellites, whether it's open source or commercial satellites. So affordable and quick delivery is really the sweet spot. So our suppliers are spread all across the world. We had originally were approached by Maxar to see if we would represent them. They're based in Colorado in the US. And then we were approached by some Chinese operators who have offices in, say, in France, but really when it gets down to it, they're Chinese. And then another Chinese company called Spacewall. And then Pixel, who is actually Indian, but it's easier to get money if you've got a Californian address. So they've got an address in California, who do hyperspectral. And Capella, who are radar satellites based in Silicon Valley. Talk about them. And then lately, SI Imaging out of South Korea and NTT Data out of Japan. So, and down here, I had no idea that it was a Uruguayan company with a satellite constellation, but we now represent them, called Sapologic. So we just quickly work through, I can show you some examples of these different suppliers have, sort of thing they supply. So Maxar, you see plenty of this imagery on the internet or on the TV news, you know, showing pictures from Ukraine and with a nice little logo in the bottom. So here is a subdivision in Auckland that we were monitoring a couple of years ago. And so you can sort of see what, as far as you can zoom in before it starts becoming pixelated, but it's good to see the state of development, you know, finished houses here, nice new roofs, Matt. And, you know, still under construction over here. The nice thing about Maxar is you don't have to order images one by one. You can actually take a subscription, and that gives you access to their entire archive of 20 years worth of imagery from all over the world. And you just basically pay as you go. You might pay an upfront fee of, say, $8,000 to get 2 GB access that'll last you a year if you're a careful user. And if you run out of data through the year because you've got some projects, you can do a top up just like you would with your mobile phone, just with another couple of zeros on the end. So this resolution is typically 0.3 to 0.5 of a meter native without the enhancements, and can be 4-band or 8-band multispectral if you want to get more data out of it for machine learning, etc. The big thing for Maxar is that they're launching 6 new heavy-duty 0.3 meter satellites starting in January. These have been promised for a while, but they assure us they're going to start launching in January. And once they get these 6 new ones up there, they're going to provide up to 15 revisits a day. So that's a real game changer. Spacewall is based in Beijing, and they have a constellation of similar sort of satellites to Maxar in terms of the resolution, 0.3 to 0.5. It's a lot more tasking based, whereas Maxar is doing more speculative capture as well as tasking. But Spacewall can do daily revisits anywhere in the planet, and the latest thing is their 2 new NEO satellites at 0.3 meter resolution. And their plan is to have 16 of these high-res satellites. And I guess they don't make too much fanfare. They just tell you when it's up there and working, rather than sort of have a large number of announcements before it happens. So this is a sample picture from around the Ashburton area. And you see, quite clear, and they took that without any fuss as a sample for us. Head Aerospace is another Chinese company with offices all around the world, particularly in Europe, and they are a representative of quite a few of the different constellations that Chinese companies run. it's just mind-boggling how many satellites are flitting around that we've got no idea what they do until you start getting into what's available. So they've got access to 91 different Earth observation satellites. So you think about that, and most of them have got different capabilities. The amazing capability, I feel, is these 3 Earth scanners they have, and this is Earth scanner imagery in the sample. So it picks up in pixels at 0.75, and then they'll publish them at 0.5, so they do the super resolution processing on it. So not quite as good as the super view. These pictures are typically 12 kilometers wide. These pictures are 150 kilometers wide. And, you know, it's easy to find examples where they've captured Whangarei down to Dunedin in a space of 3 minutes. So basically almost the width of the South Island as the satellite flicks over. Down at the sort of more detailed or more precise level, if you're doing tasking, you've got the Daily Vision constellation, and they've got 18 revisits a day. And in the mornings, between 9 and 12:30 there, they can target every 15 minutes. Now, obviously, that's got some applications if you really want to know what's going on somewhere. And I don't think we've got many people in New Zealand who want to task that often, but it's all possible. And then other pretty clever hyperscan, a couple of these satellites go around, picture and cover very large areas at very low cost. I'm talking a couple of dollars per square kilometre. And they'll pick up multispectral, hyperspectral data at different resolutions every couple of days, and they'll do medium resolution, normal imaging. So again, I haven't found anyone that's paying for this or actually using it, but there's huge amounts of this data over in New Zealand for the last few years that's available for purchase. And then we won't get into them, but as we go down the resolution to bigger pixels, there's a lot of special purpose agriculture and environmental monitoring satellites that are flitting over. And all that data is available, very low cost. Our challenge is just making sure people know about it. So it's great we've got this opportunity. Out of South Korea, these are probably the last ones that we signed up to be a reseller for, and they were very low key. Approached it a couple of times, and then they quietly said, we've got a large amount of data over in New Zealand. And so we started sort of looking into it, and what we've discovered, these 2 satellites here, CompSat 3 and 3A, at this 0.5 meter type resolution, are capturing on average 250 scenes a month over New Zealand, and they've been doing it for 10 years. So there's an amazing archive of high resolution imagery covering all of New Zealand for the last 10 years, all taken with the same cameras. So there's a homogeneous archive there. And they also have a CompSat 5, which is a radar satellite that can get down to 1 meter pixels, or actually just really big, sort of hundreds of kilometers square, with say 30 meter pixels, and in between you can set it to what the pixel range you want. And I'll get into some radar in a couple of minutes, and you can see the difference. So coming back to these CompSat 3s, so these are the nice imagery. It's all very well to say 250 images a month, or 3,000 in the last year. This is what it looks like. This is the coverage in the last 4 years, and just incredible amount of detail available. And this goes back to 2013 when the first one was launched. And we say, why have you done this? And basically they say, well, we could. And as the satellite comes up under Antarctica and back over New Zealand heading towards Asia, it's a nice fine day. They've just taken pictures. And I think as a country, we should be taking advantage of that. So Satellogic is a Uruguayan company. Uruguayan and Argentinians set this up. They're now listed on the NASDAQ Stock Exchange, New York. And they have a plan to remap the entire planet every day. And they're on target to do that by 2025. So currently, they've got 26 satellites in orbit that capture natively about 1 meter resolution, and they post-process that down to 0.7. And here's an example. It's not particularly bright because that was taken as a sample for us in Ashburton in June or July. So it was middle of winter, and you can see the long shadows. But you can see the shadows here of probably poplars or something, stripy. So you get an idea of the different types of trees by actually looking at the shadows and how high are they. You can work that out from simple trigonometry. So we're getting 5 revisits a day with Satellogic. Their claim to fame is really quite low cost tasking and quick turnarounds. And by 2025, they'll be doing 40 revisits a day. So next year, they're planning on being able to do monthly remapping of the entire planet with 40 satellites. They're actually building them, this 200 in a factory in Holland at the moment. So then we get into radar, and this is particularly fun. The fun thing about Capella is basically anyone that's a registered user has control of the satellite constellation that Capella has launched. And these are radar satellites that can see in the dark. They can see through cloud, through smoke. So through rain, we don't care about the weather. We know we can always get an image, which is kind of handy. So this was topical, of course, a year or two back. And so we asked them to grab an image for us that we could use for publicity. And normally, this is the crater in White Island, and it's steaming away normally, so you don't get to see much. But the radar just takes all the steam out. You can see right into the crater, and there's some lump here. If you look carefully along here, you can actually see walking trails. Not many people walking it these days, but that's what was going on. You see all the little rivulets from drainage here. Because radar satellites are always taken obliquely, the images are taken obliquely, you get a different view. You get foreshortening, so slopes that are close to you appear a bit more distorted and far away ones. But basically, get white is strong reflections and dark is poor reflections. So water, the ocean and the crater lake appears dark because the radar beams and microwaves are just bouncing straight off, not coming back to the receiver. Up in here, this was taken at 10 o'clock at night in June 2021. That's a boat. So someone was visiting White Island under the cover of darkness. We got some imagery taken around February this year when there was some danger of flooding in the west coast around Westport. That was, on top of the one they'd had a few months before. So here's the Buller River around inland, and it's quite obvious what's going on. There's a little bit of flooding here in the black bits. And the white thing here is a bridge across a tributary. So this is the platform you get if you're a Capella user. You can just sort of plug in your own tasking requests for particular areas. It tells you what time. You've got options. You pick one. It says what the cost is going to be, and you either accept it or don't. So this is cool. You need to give about 3-4 hours notice, and then maybe 2 to 4 hours before you get the imagery after the image is taken, after it downloads to an Earth station. And this is what it looks like. So this high resolution spotlight, 50 centimeters, taken during flooding. So here's the traditional lens imagery we're looking at. There's a house here with if you know the West Coast, they do this humps and hollows where they sort of move the earth and break up the iron pan. So you see it, and you see how it's the floodwater is right around this house, and here the floodwater is just sitting in the low parts of this paddock here. And I initially thought, you know, this looks like an amazing sort of caravan park or something, car park. What on earth is it? And when you look, it's actually the graveyard. So it's a cemetery. There's quite a few people in there. I've got a cat that's trying to get in the door here. It thinks it's afternoon tea time. So we talked about a little briefly before about hyperspectral, and Pixel is a very new company that's coming out of India, and some sort of young fellows in their early 20s decided they wanted to be have their own satellite constellation, and it would be hyperspectral they would focus on. So they got funding, and they're in partnership with Maxar and a few others, and they just launched their first sort of real trial satellite in the last week or so. So hyperspectral is basically, it picks up many, many hundreds of different wavelengths of light. Multispectral is picking up maybe 8 or 10 or 20 prescribed wavelengths, and the normal RGB is red, green, blue, and you merge them to make the pictures that we see. So hyperspectral is a hell of a lot more data within each pixel, and basically what happens then is you look at the shape of the spectrum in each pixel to pick up different minerals or different vegetation types. So you're looking at the shape of the spectrum rather than the color of the spectrum. So it's quite different. So their aim is to have a constellation that provides global coverage every day for monitoring what's happening on the planet. They do have an early adopter partner program. We're part of this, and part of our role is to find other people who want to be early adopters. So if you are one or know of one that's interested in sort of getting in early on this and trying it out, Pixel will be very happy to accommodate you. And then coming back down to what can we do with all this data? NCT data out of Japan is basically mapping the planet at this resolution. And again, it's all computer processing that does it. So they'll take multiple satellite images, like 10, 20, 30 images taken from all different angles, and use their computer systems to combine them to build 3D models of the surface. And then this is used for obvious sort of users, search and rescue and things, but in cities for radio frequency planning is a common use. And, you know, they just quietly sort of mentioned, yes, we've just completed the 3D model at this resolution of the entire United Kingdom. So, you know, I'm pretty proud of the partners we've developed and the capabilities. And, you know, many of these companies have hundreds or thousands of employees. And I think as New Zealanders, we tend to be a bit insular down here. There's amazing stuff happening in the mapping space around the world, and people are very happy to share it with us. So I'd encourage you to have a look at our website, and here's the URL for Satellite Imagery Marketplace. There is this shortlisting tool, which is pretty simple. It's just side-by-side imaging. You can look at Sentinel-2 versus SuperView, or you can put Maxar in here, and down in the field here, it's going to tell you where you fit. So this is free data. SuperView is sort of 4 out of 6 in terms of pricing for archives. 5 out of 6 if you're going to be tasking it. I'll tell you quickly what the minimum area is. So 100 square kilometres, not that big. It sounds big. It's 10 kilometres by 10 kilometres. And archive order minimums, and they all vary. It's got 4 bands, and it's got 4 bands. You can't task Sentinel, you can't task these guys. And so we've got plenty of samples, and you just drag and drop, move one, and it moves the other one around if you've linked it. So that is our presentation, and I'll stop sharing.
Thank you, Steve. You've timed that pretty well. Any questions there for any of the satellite imagery or things that Steve's shown today?
Steve, Matt here. Great presentation. Thanks. One of the challenges in the past has been sort of that minimum area requirement. Are you seeing that shifting around? Are some of these newer providers allowing, for example, 20 hectares or 30 hectares, or mapping a farm or a wetland or a riparian area? So my question is, if you're forced to buy 25 square K to map 1 square K, it's hard to make that work economically.
Yeah, no, that's exactly the case, and we find it hard too. So we have to put a service fee on top of the square kilometre rate just to sort of make it even viable to discuss it. It's kind of a race to zero. That's where some of the subscriptions do fit in, because they become more self-service, and you can download, say, 1 square kilometre, which is still 100 hectares, but it kind of makes more sense. But then you've got to be downloading a lot of those to make sense. So I think we can encourage the New Zealand government to sort of pay for a lot of this stuff and make it open data. That'd be wonderful, but could be a hard sell.
Well, a public sector subscription sounds like it could be a good opportunity, couldn't it? If I know there's sort of, obviously, if you look at sort of vegetation mapping now on farm for carbon sequestration, there's a lot of water resource requirements on farm, things that could be used for, say, sub areas of public sector.
Yeah,
under one subscription,
that'd be a great idea.
Maybe solve that.
Down at the sort of 50 centimetre type level, it's sort of multi-purpose, but actually really useful.
Yeah.
And we're sort of trying to talk to a few people about that. But you know how that works.
Yeah, but great to talk. I'd like to come and see you, Steve, and catch up on the service there.
Yeah, do that. We have plenty of pixels in the cupboard.
Great. Thanks, mate.
Thanks, Matt. Any other questions springing to people's minds? We've got 4 minutes before 3 o'clock. Or as usual, if they come to you later, feel free to get in touch, and we'll share contact details for all the presenters. And we might move to wrap up there. So thank you, Steve. Again, really interesting presentation on the different capabilities there. And it's amazing how many satellites there are up there looking down on us. Thanks again, everyone, especially all of the presenters today. Yes, we'll be providing the recording and some minutes in the next week or so, and the next meeting otherwise will be another 3 months, will be probably late March. So otherwise, I just want to say thank you again for everyone giving your time today to speak and to attend. We really have enjoyed putting these on this year, and looking forward to a great next year ahead. So have a great break, all of you. It's been a bit of a tough year on top of tough years. So everyone deserves a holiday and a great summer. And we will, see you all again in the new year.
Thanks, Ben.
Cheers, Ben.